One of the things I'm passionate about is continuously improving engineering education. And we're now engaged in a exercise we call NEAT, the New Engineering Education Transformation, to really deeply examine engineering education at MIT and hopefully improve it, move it in a better direction. This is not to say that it's broken. This is to say that it's a subject of continuous process improvement. And we very much want this to be aligned with the needs of industry, both the industry of today and the industry of tomorrow. So one of the main themes that we have in this deep look at our engineering education is the idea of the new machines. The mission of MIT is to prepare people and ideas for the 21st century. So we should think about that in our education as well. So it's reasonable to ask not what did our teachers and our teachers' teachers build, but what will our students build in the middle of their career, let's say in the middle of the 21st century. And you can speculate at a lot of things, you know, the Internet of Things, highly autonomous systems, self-driving cars, much more technical and smart cities and infrastructure, biological devices. And any one of these particular items may or may not come to fruition. But if we look one layer below that, we can see a trend. What are the trends? The trend first is they're all everything. They're all electromechanical, biological, informational systems. There's no mechanical system left. Nobody can fix their car with a wrench anymore, right? You need a software tool to fix your car. So they're all highly integrated from a disciplinary perspective. The second is, as we discussed earlier, the second point is they're increasingly complex as they are. You know, the car you drive has 4 or 5 data buses on it now, and data security systems. The car you drove 15 years ago didn't have any data buses on it. So just the car itself is becoming increasingly complex, or the airplane or the robot. And then as an additional point, these increasingly complex things are all getting interconnected, so that a security breach in your car can be caused by a hacker in Taiwan, and so forth. We need to think about sustainability, that we have to use energy sources and we have to use materials that will be increasingly sustainable. So these are the sort of themes that we're building, thinking about how to build into the education. And it really has the potential for significantly transforming sort of the view. Yeah. How would we prepare students to build these new machines? The other factor we have to think about is that the pace of development and the generation of new scientific and technical information is accelerating. The idea that you can send somebody to college and they get a lot of just-in-case information, just-in-case learning, is sort of an idea of the past. As I like to say, the last time you could be a Renaissance man was the Renaissance. You know, the last time you could actually know about everything there was to know about was 400 or 500 years ago. So we have, on the other hand, the observation that this generation of students can teach themselves almost anything they need to learn on the internet in a matter of hours. In fact, sales of textbooks are diminishing, even in subjects where there's a required textbook, because students know they can either find a PDF of the textbook online, or they can find the other material in somebody else's open courseware notes from Berkeley or Stanford or Michigan. So they know how to teach themselves facts. So the question is then, what's the value of going to university? It's not just finishing school. We have to have some value-added process. And I think very much we're coming to a view that the value of university, especially a university like MIT, is teaching students how to think, not in a general way, but in fact in a very set of specific ways. Thinking about analytics, thinking about computation, thinking about experimentation, thinking about humanism, which is a very complex idea of non-qualitative thought about our society and our history. Thinking critically and creatively and thinking about systems and working, having values and working with others. And then we get to the end, where we want to think about whether our students are going to be makers or discoverers. And I think, and many people think at MIT, maybe we've weighted a little bit, we've put a little bit too much weight on the discovery side. And we have to recognize that our students will graduate and go to work on a spectrum from being discoverers, that is to say researchers, to being makers, that is to say engineers, and that we should prepare them all along that spectrum. So we're actually engaged with the ILP in surveying the needs of industry, the views of industry on this point, and it's one of the excellent applications of the ILP network to the improvement of MIT, because we use it as a way to get the voice of our customers, the voice of industry, to help guide our solutions.